Okay, so let's see this problem. Here the trajectory is given. We need to find out the law of the force. Okay, so particle describe the parabola, this one, which is given under a force which is always perpendicular to the y-axis. And our question is to find out the law of force, and the second part, velocity at any point of its orbit. Okay, so first let us concentrate on the first part. So what it is saying ki now the force is unknown to us. Only it is given ki it is perpendicular to the y-axis. We know nothing about its magnitude, and it is given ki the trajectory is known. So that is the thing ki trajectory is a parabola. So the thing is ki we know the in the 2D plane our particle is moving something like this, and I make it a more bit precise. Okay. So this thing, so at any point, if I consider the position of the particle, x, y, okay. So with respect to t, this x and y depends on t. Okay, so that means x itself is a function of t. Again, y itself is a function of t. So when t is changing, our points are also changing. So suppose when t equal to t1, our point is at here. When t equals to t2, let our point be at this point. Okay, and so this continues along the entire trajectory. We have shown it here. So what we need to do it now? So one thing is clear, ki from here, what is the given trajectory? I can find out x dot, I can find out y dot, I can also find out x double dot, y double dot, because every x and y as their functions of t, and obviously they're smooth functions here we are taking. So we can differentiate it, right? We can just measure the rate of change with respect to time. So once we get this, and again we call back, we need these things to frame the equation of motion. And for that, we will need the force which is acting, whatever force is given to us. They have denoted as capital P here, whatever the relation, I will just check once again. So we can use it right now to frame the equation of motion, to use this P in this equation of motion, and then use the trajectory, whatever trajectory is given to us here, to find out this x double dot, y double dot, everything in terms of t, and then ultimately eliminate t to find out p in terms of x, in terms of y, whatever will come. Let us see. We do not know right now. So let us go back to the problem. So as I said, the force always perpendicular to the y-axis. Okay, so always perpendicular to the y-axis means here, this is the y-axis hour. So always perpendicular, that means this direction or maybe in this direction. I do not know right now because we have no further information provided to us. So let us check what happens. Acha. So one thing you just clarify from this part, if it is like this or this, so what is our structure, or whatever we can say about x double dot, or whatever we can say about y double dot confidently, I can say this y double dot, there is no path. Because you can see whatever force is acting, it is acting parallel to x-axis. There is no component parallel to y-axis. So definitely it is 0. And whatever we are assuming or using the symbol P, so it is P here. Okay. Whether it will be plus or minus, everything is right now involved within this P. When the law of force is determined completely, you can see whether the plus comes or minus comes. If the plus comes, then it is in this direction. If the minus comes, then it is in this direction. Okay. So let us now see. Just straightforward, we can consider the trajectory. Hmm. And before that, way from y double dot equals to 0, we are getting y dot equals to some arbitrary constancy. And this will remain arbitrary because we have no other information to sort it out or to make it fixed. Okay. So from here, you can differentiate to find out x dot, x double dot, and then you can just easily plug it, this 8y from y dot, you can use this thing to include c here. So ultimately, just after a bit of simplification, so it's very straightforwardly, you can get x double dot equals to this. So what is the main thing? Minus is there. So as I said, it is directed towards the y-axis. Okay. And whatever the you can see, it is proportional to 1 by x cube. So this is the law which we were trying to find out. Now let us move to the second part. Velocity we need to determine, right? Velocity we need to determine. Now to determine the velocity in two dimension, what we need x dot, y dot, because we know from our previous lectures, v has two components, x dot along x-axis, y dot along y-axis. So its magnitude is given by the resultant formula like this. So you can simplify. And what is the direction? Direction is given by tan theta of y dot, that is the y component by x component. So this again, you know y dot, x dot, you just plug in all the values here rather the expressions here, and you get the ultimate direction also. So this magnitude along with the direction completely specify the velocity of the particle at any point you choose on the trajectory. So this completes this sum. Now let us move on to the next one. So here it is saying a particle is moving in one plane under a force which is always perpendicular and towards a fixed straight line on the plane. Okay, and its magnitude is this mu by distance from the line square. If initially it be a distance 2a from the line and be projected with a velocity this much parallel to the line, prove that the path is that is traced out is a cycler. Okay. So let us break all this information part by part. First, we need to understand how our trajectory or how our point is moving rather. Okay. So it is moving under in one plane, so two-dimensional under a force. Now the direction of the force is very important. We need to frame or rather draw the diagram, which is always the force is always perpendicular and towards a fixed straight line on the plane. So let us see what the figure they are giving here. Perpendicular and towards the fixed straight line. Okay. So whatever we are taking, say so one thing is clear to us. This is the plane, whatever you may say. hmm, A fixed straight line is given. Okay. For this sum, they are taking this as a x-axis. Okay. You may change it and take it as a y-axis. Also, then your all this approach which you will be following right now, I will be just considering only that done in the book. You can change and consider this as a y-axis also. Whatever. Anyone you have to choose. So this is a fixed line, right? It will not change no matter how much the particle is moving. So let us consider this as one axis. The main motive is that the fixed straight line, whichever it is given in the sum, you consider it as one of your axis, either y-axis or x-axis. We are considering it as a y-axis. So once you frame that, this is x-axis fixed, so you take another one perpendicular to it as a y-axis. Okay. So now, once we consider this one, then we use whatever the force is given to us. It is perpendicular to this one, fixed straight line, and it is of some magnitude. So we will use all those things here. Okay. So for what? To frame the equation of motion, and then part by part differentiation we do one after another, say first order, second order, to find out x dot, x double, sorry, not dot, just the reverse thing to find out first x dot and then x, and then use it as per the problem. Okay. So now let us see what they are saying it right. So once you get this idea, this is the at any point P, your position of the particle, the force is acting perpendicular to the fixed line which we have considered as a x-axis. As I said, you can reverse the situation. So what will happen in that case? The equation of motions and corresponding changes will occur. Okay. So once I take that, x double dot equals to 0 as per our assumption, x double dot equals to 0. Achha. As what we were saying, you need to write it down. For exam purpose, I am saying you need to specify, because otherwise how will one know which one you are taking as your reference x-axis and which one as your y-axis. So they have already said refer to the given fixed line as x-axis and the line perpendicular to this to the point of projection. Projection means again the initial point. I already said before for simplicity, for simplifying the steps, we all consider the origin as the point from where we are projecting the particle. Okay. As the y-axis, that means perpendicular to the x-axis of the y-axis. So pxy position of the particle at any time t. So once you are doing this, you are getting the equations of motion like this. At the equation of motion, in equation of motion, you see x double dot is 0. I think this is clear right now, because as you can see, the force is like this. So no force parallel to x axis, so x double dot 0, because no acceleration also in that direction. And y double dot equals to minus of, because it is directed towards the x axis, and y is increasing in this direction, above direction, and your force is just in the opposite direction. So minus is obviously justified here. Okay. It's better if you just give the reason also here, mention the reason, since your force is directed towards the x-axis. Okay. Then this minus sign will be justified. Just please mention this in the right hand side as a reason. Okay. Then you integrate once from this here, as we already do, just integrate once and then use initial condition. What is the initial condition? Now for the initial condition, let me see the other half of the problem, which is given. If initially it be at a distance 2a from the line and be projected with a velocity. So it was not at rest, it was projected with some velocity. That means initial velocity is not 0. And what is the direction? mu root over mu a parallel to the line. That means parallel to the x-axis. Okay. So that means x dot has some value and that is equal to root mu by a, and y dot has no value initially. Okay. So x dot equals to root mu by a, we should put, let us see, we are putting it. See here, x dot equals to root mu by a. So from here you can find out c, plug it in here. So x dot equals to this one. You again just integrate it. Okay. So this thing you are getting from here, and initially t equals to 0, x equals to 0, because we have considered origin as the point of projection. So obviously x equals to 0. So c dot c dash becomes 0. So this is the x equals to thing we are getting. Again, now what we are doing, we are moving. Let us see. Okay, let us now understand what we are trying to do. That is the most important thing. So we are using the initial conditions. Okay, and we try to find out, or rather prove, that the path is out. So the main thing, what is our motive? Please find out the path. So how can we find out the path? Either it can be a parametric one, that means with respect to some parameter theta or something, t, x and y should come, or it may be an explicitly in terms of x. Hmm. So as we see from here, or rather we just can understand once we progress further, the path will be coming out as a parametric path here. And it is a cycloid, that means of this form. Okay. So we need to find out x, y, right? So x already some progress we have made like this. And now we are starting to deal with the y double dot. And here in y double dot, see, we are using that technique again, multiplying by 2 y dot and then integrating so as to get the expression of y dot square. You get the expression of y dot square from here. Okay. Then y dot square from here you are getting, again you are using the initial condition. Hmm. So once you are using the initial condition, y equals to 2a, where from we are getting this, this is also given to us. It was initially the distance 2a from the fixed line. Distance 2a from the line. So what is the line as per our assumption? X-axis. So it was at a distance of 2a from the x-axis. So this is OA, the 2a from the x-axis. So that means we are getting here y equals to 2a when t equals to 0. Okay. So here, and y dot is what? 0, because as we said, we projected it along x-axis. Okay. So we are plugging all these values so as to get y dot equals to this. Okay. Y dot square. Let me just first focus on this. Y dot square equals to this. Then you are putting y dot equals to, obviously square root is coming, but the negative sign is also coming. They have justified it properly, saying why? The force is towards OX, as I already said. It is acting towards OX, that is trying to bring you in this direction, but your y increasing direction is just in the along positive direction of y axis. I think y is increasing upside and your all motion is taking place along downside. So obviously the minus is justified. So velocity is decreasing in this case. So y dot minus sign is taken here. And then you just perform this integration and just please note down the range of the definite integral which you are using. When t equals to 0, then your y value is 2a. It was at a height 2a. When t equals to any value t, that means it is just a symbolic, it is variable. Then y is also variable. Y. Okay. Then you just can integrate it. For integration, they are using the substitution so as to just simplify it. There's nothing to explain here. You go through this, and then what you are getting p in terms of this, right? So if you are getting t in terms of this, please recall back, already I have obtained, or rather framed x equals to 2 over mu a by 2. So once you get t in terms of the theta, you can plug it in equation 3. So that you get x in terms of theta. Now what is theta? Theta is the parameter here. Why parameter? Because it's variable. Where from you are getting the variable? Via the substitution. And why it is needed to replace the y. Okay, so when y, what is y's nature? It is variable. As I said, it is dummy variable. It is varying as the point changes its, as the particle changes its position from one point to another, y goes on changing. T goes on changing on left hand side, y goes on changing on the right hand side. And for the y, we are using this theta. So obviously theta is the parameter here, nothing constant part. Okay. So x is becoming a function of theta. And similarly, y equals to already, as per our substitution, y equals to a cos square theta. So you can easily guess it is 1 plus cos 2 theta. It's 1 plus cos theta by 2 is here. So you are getting like this. So this is the parametric equation of the path traced by the particle. And obviously it is representing a cycloid. So this ends up the sum here.